All right, hi there. So here is a recording for the pre-lesson on rational expressions and rational functions, all right? So if you guys have any questions for me, as usual, please let me know. All right, so let's see on how we are going to answer this. So first thing we want to do whenever we are simplifying rational expressions, right? We want to see if we can factor both the top and the bottom to make our life easier. So if we look at this exact one here, right, we look at the denominator, we will want to take out the greatest common factor, which is going to be 2x. And so once we factor it, right, at the bottom, we are going to get 2x times x minus 9. And then from here, we want to, simplify our fraction, essentially. So we look 10 and 2, they're both divisible by 2, right? To give us 5 for this, and this is 1. And then remember your exponent rules, x cubed divided by x is going to give you x squared. So then from here, we will get 5x squared divided by x minus 9. And this is how you simplify rational expressions, right? Or at least the part of it. The next thing we want to do for this another example, right, is as you can see, this one, as usual, if you remember, we always want to take out the greatest common factor first. For the numerator, that's going to be 3x. And then we are left with x squared minus 5x plus 4 divided by, and then this one also has the greatest common factor of 3. So that gives us 3 times x minus 1. Right? And then let's see. The next thing we want to do is to factor the quadratic. So remember the butterfly method. If we are to factor it, you get 1, -5, and 4. And then remember, it's trial and error. So we want to try and see what will work. After trying and seeing, I'm seeing that -4 and -1 work over here. Right, we group them, and we add them, and they do give us -5. So that means my factor is x minus 4 times x minus 1. So I'm going to write that on top, right? The -3 doesn't go anywhere. We just place it there again. And then we have this. Great. Now we want to see, right? Because remember, like fractions, we always want to see what the top and the bottom can be divided by, meaning whether they both have the same. If it's whole numbers, like as you can see, these threes, they cancel each other, right? Because they're both divisible by 3. And then we see, oh, the numerator and the denominator have x minus 1. So those cancel out. Excuse me. So then we are left with x times x minus 4. So your answer could probably give it to you like this, or you could also expand it like this. So either or, these two would be correct. All right. It just depends on how the answer gives it to you. Next one, multiplying and dividing rational expressions. So same thing as usual when we, it's like your normal fractions, really. The same rules literally apply, right? So if we look at that first one, we want to look at a top and a bottom. So essentially a numerator and a denominator. It doesn't really matter whether they're on the same fraction or it's on a different fraction. As long as it's a numerator and a denominator, you can simplify. For example, if we look at this 12 and we look at this 6, right? 12 and 6, okay? We know that they're both divisible by 6, right? This will give us 1, and then this will give us 2. Not only that, x squared, x cubed, that leaves us with -1, so that's why we leave x at the bottom here. And then 5 and 20 are both divisible by 5. And then y to the fourth divided by y to the third, right? That leaves you with a single y, as you can see, right? So then, as you can see, we're left with, if I'm going to write it all, my fractions clearly, right? Or at least what I'm left with. I'm left with this. Now, again, as usual with any other kind of fractions, we want to multiply. Well, once we simplified everything, we multiply the numerator with the numerator and the denominator with the denominator, right? So 2 times 4y is 8y, 1 times x is x. So this is going to be our answer, all right? Next one. So same concept, except that if you have quadratics like this, you do want to factor them first. So I'm going to write out what we have before we get into simplifying. Now, because I know that this is a difference of squares, right? Because the coefficient is 1, this is 25, and they're both perfect squares, and this is a difference, so minus, right? I'm just going to take the perfect squares, or the square roots of the perfect squares, and then just put plus or minus in front of one of them, like this, all right? From here now, I can simplify whatever I need to simplify. So here, x minus 5 cancel out, x plus 5 cancel out. And so essentially, as you can see, on the top here, we're left with nothing. So we actually, we still didn't need to put a number. We're just going to put 1 over, and then we're left with x minus 5. And that's how we simplify rational or multiply with rational expressions, right? So you cannot just put nothing on top here. You will have to put 1. Okay. Next one. So the thing with dividing fractions, and this goes even with like your regular fractions, right? Like the simple like 1 minus 2 divided by 3 over 2. The first thing you need to do, right, is actually hit, switch, flip. Okay. So you keep the fraction that's on the left as itself. Oh wait, actually this is a time sign. What am I talking about? So we'll actually see this later down here. There we go. So if we bump to this, right? Keep, switch, flip. Keep this, switch this to a time sign, and then we flip this upside down. But we'll get to that in a second. Jump the gun a little bit. So this one, yes. Same thing as usual. We want to factor our quadratics. And then this one over here, if you notice, right, I'm actually just going to factor out a negative sign. So I switch it around, and you'll see in a second why. All right. This one, greatest common factor is x. And then if we factor this, so by now, right, if you're my student watching this, you should be proficient at factoring quadratics, because that is a very important skill that you need to have, because you will always see it on the questions, right? So, right, if we factor this, we would get x plus 7 times x plus 3. And then for the bottom, difference of squares, x plus 7 divided by x minus 7. Okay. Now from here, I'm going to cross out everything that, can be simplified. So x minus 7 here, x minus 7, x plus 7, x plus 7, x plus 3, x plus 3. Great. Now, as you can see, right, I'm left with negative, and then pretty much all the factors on top are crossed out. So it's actually negative 1 over x. And really, that's it. That's my answer. All right. So if so far you have any questions about simplifying your rational expressions, please send me a text or an email, all right? Or sign up for a one-on-one session. Now on to dividing your fractions. Okay, so remember, keep, switch, flip. Keep the fraction on the left, switch the divide sign to multiplication, and flip this upside down. So if I'm going to rearrange it right now, it's x squared plus 7x plus 10 over x squared plus 4x plus 4 times x squared minus 4 over 1. That's literally just it. Now I'm going to factor everything. So when we factor it, we should get x plus 5 times x plus 2 divided by x plus 2 squared times x minus 2 times x plus 2 divided by 1. And we simplify. So let's see. X plus 2, so cancel out that exponent, and then another x plus 2 over there. And then as you can see, we're just left with x plus 5 and x minus 2. So if we were to rewrite it, it'll be x plus 5 times x minus 2. So your answer could give it to you like this. And also, just remember, because it's divided by 1, we actually don't really need to put this over 1. It's fine. So your answer could give it to you like this, or it might even ask you to distribute the parentheses. And if you do distribute the parentheses, you would get your final answer as this after even grouping the like terms. All right. So yeah, 2 ways of the answer options giving it to you. It's either this or that. Either way, they're both the same thing. All right. Next one, with adding and subtracting rational expressions. So again, right? Even though now you see your X, Y's, maybe even other letters in these, right? At the end of the day, rational expressions are just fractions, right? So the things that you learn in like first and second grade about fractions is still being applied to rational expressions. It's just now that it's a little bit harder because you have, your X and Y's. So if you remember about adding and subtracting fractions, first thing you always need to check. Do they have a common denominator? And this is what you need to do with um, rational expressions. If you have quadratics like this, factor it out first, because then you'll see what we might be missing, right? So from here, we have x times x plus 1. So as you can see, right, actually on the left here, we are missing x plus 1. The common denominator is actually going to be this, right? So normally with rational expressions, just ask yourself, what is the common denominator? And then you want to see what each fraction is missing. So like I said, this fraction is missing x plus 1. So we multiply the top and the bottom with x plus 1. This would then give us 3x plus 3. And then I'm actually also going to just put this into a single big fraction. So plus 1 divided by x times x plus 1. And generally, I like to keep this still as factor form because every once in a while, even after like solving this, you may be able to simplify it even further, right? So I just like to keep the denominator still in factor form just in case. So from, let's see, we group the like terms, we get 3x plus 4 divided by x times x plus 1. And that's the answer, right? Just because I know the top, I can't take out any greatest common factor or anything. So we're good with this one, all right? Next one. So same thing as usual. We always want to ask ourselves first, whenever we're adding or subtracting any kind of fraction, do they have a common denominator? So as you can see, they don't. Actually, if anything, they're both missing each other, right? So you want to take them as in the factors like this in parentheses. You don't want to take them separately, like, oh, they both have or they both have 1, they're missing just a negative x and a positive x. Nope, you want to take it like as a group like this. So actually, for the the fraction on the left, you need to multiply it with 1 minus x, and oh, there we go. And the fraction on the right, you want to multiply this with x plus, 1 plus x. Okay. Once we distribute our parentheses, we would actually get, and also be careful, there's a negative sign here. So I'm just gonna put negative, and then we distribute, right? We would get 2x minus 2x squared. Let's see, minus 1 plus x minus, wait a minute, hold on. Pause for a second. Hold on a minute. Okay, so we had a little blooper, right? You might have seen a time skip. So actually, here's what the first thing we want to do. We have to actually factor this out. So if we factor that out, right, we would actually get negative 2x minus 1 times x plus 1 divided by, if we just rearrange this, it's x plus 1, minus 5 over 1 minus x. Okay, and as you can see, oh, these two actually cancel each other, right? So then if we were to rewrite our fraction right now, we have negative 2x minus 1 over 1 minus 5 over 1 minus x. So actually, right, what these two fractions have for their common denominator is going to be 1 minus x. So I'm going to multiply here with 1 minus x. I'm also multiplying that with 1 minus x, okay? This would then give us negative 2x minus 2x squared minus 1 plus x over 1 minus x minus 5 over 1 minus x. Distribute the parentheses here. And I'm also going to bring this over and put into one big fraction, right? So we have negative 2x, actually, yeah, negative 2x plus 2x squared plus 1 minus x minus 5. Why minus 5? Because this is a minus sign, so it does affect that. All of this over 1 minus x. Now we group our like terms. Let's see, we got 2x squared, and then negative 2x minus x is going to give us negative 3x. 1 minus 5 is negative 4. So as you can see, we would get this as our final answer. Another possible way that they could show the final possible answer is if we just take out the negative sign here, right? It becomes negative 2x squared minus 3x minus 4 divided by x minus 1. So either way, these two are literally the same thing. There's just different ways to write it. All right. Next one. So these, I would say you do see them equally on both the ACT and the SAT. If anything, right, most likely asking to find what value of x will make the function undefined. You do see that actually both in the ACT and the SAT. More specifically towards the ACT is identifying the coordinates of the whole, right? That one rarely comes out, but this is how you want to answer this, right? So in order to see, right, actually let's answer A first. So really, as usual, we factor this first. And once we factor it, we would get x plus 3 times x minus 2 divided by negative 4 times x plus 3 times x plus 1. All right. Now, if the question is asking you to find a value of x that will make the function undefined, all you really need to do is just find what will make the denominator equal to 0, right? Because if you remember anything about fractions, we can't have anything divided by 0. That will give you a math error. Even if you put in a calculator, math error. So really, if their question asks you to find what value of x will make the function undefined, just look at what would make the denominator equal to 0, right? And the easiest way to do it is factor it out first, and then for the factors that do have x, right, we place it out like this. So x plus 3 equals 0, x plus 1 equals 0, and then solve for x. X equals negative 3 and x equals negative 1. And then you actually try it out, right? If you plug just these two numbers into the denominator, they're going to give you 0, right? So that means we have found our answers where x cannot be negative 3 or negative 1 because it would make the function undefined. And so these are the two numbers we want for our answers, right? Similarly, wholes, right? So essentially wholes are just a single point in a rational function. If you were to ever graph it out, where if you plug that number in, it will make the function undefined. More specifically, right, how we want to solve it, right? Specifically with wholes, if we base it off the, actually, I'm going to write it, function that we have, you want to see what can be simplified, right? Like how we've been doing for your expressions before. We want to see what factors both the top and the bottom have. So if we look here, right? Oh, my mouse is not moving. There we go. Right, if we look here, we can see, oh, x plus 3, right? Both the numerator and the denominator have. When the numerator and the denominator both have that number, it actually means that it's going to be a whole at that coordinate. So x plus 3 equals 0, so x equals negative 3. So we have the x coordinate of the whole. Now is just finding the y coordinate of the whole. So in order to find the y coordinate of the whole, we are actually going to use the other parts of the function that was not canceled out or simplified, right? So we have x minus 2 times divided by negative 4 times x plus 1. And then from here, we are going to plug in negative 3 into the function here, right? So negative 3 minus 2 divided by negative 4 times negative 3 plus 1. This would then give you negative 5 over 8, right? So that means the coordinate of the whole is at negative 3, negative 5 over 8. And that's how we answer it, right? So you actually probably won't see it again in the SAT, but more so in the ACT. In the ACT, they might give you, I only seen it like once, right? They may give you this, and then they might give you like, oh, graphs, right? And they say which one would probably fit this rational expression. Just for holes, just know that it is like a hollow hole like this. Like your x-intercepts are going to be solid dots, right? Holes are going to be a hole, okay, on the graph. So they're hollow, just like that. That's, for your reference. If on the ACT they do ask you which of these following graphs is, the correct one, given that it is a rational expression. All right, last one. So this is like your rational expression that we saw earlier. Instead, this time we are going to solve for x and we're going to list any extraneous solution. Here's how we want to solve it. So as usual, right? Any quadratic expressions for your denominator, let's factor it. And so if you factor this, you would get x plus 2 times x plus 3 equals to 5 over x plus 3, right? And the reason, again, that we factor this is so that we can see what would possibly be the common denominator, right? Because the common denominator is going to be whatever each fraction combining the denominators have. So as you can see, right, both fractions have at least, or all the fractions have at least some part of, or if not all, of x plus 2 and x plus 3. So now we're going to multiply the fractions that with whatever it's missing. So like this one, we're multiplying with x plus 3. And then this other one, we are multiplying with x plus 2. We're not multiplying the middle because it already has a common denominator. Now, once we distribute the parentheses, we get x squared plus 3x. Then combine it into a big fraction, it'll be plus 2 over x plus 2 times x plus 3 equals 5x plus 10 over x plus 2 times x plus 3. And then I'm actually going to bring this to the other side. So I'm going to subtract it now. So it's x squared plus 3x plus 2. And now remember, because I'm subtracting, actually, let me just rewrite this. That way you can understand why the next step is so. So we got x plus 2, x plus 3 for the bottom equals 0, okay? And then now I'm going to distribute the negative signs into the parentheses. So we have x squared plus 3x plus 2 minus 5x minus 10 divided by x plus 2 times x plus 3 equals 0. Group your like terms on top. We get x squared minus 2x minus 8 over x plus 2 times x plus 3 equals 0. And then we want to factor this. So once you factor it, you would get x minus 4 times x plus 2 divided by x plus 2 times x plus 3 equals 0. And if you notice, oh, these two cancel each other, right? So those are going to be holes, which is actually going to be one of our extraneous solutions. And I'll show you that in a second. So now to find our actual solution, right? So your actual solution essentially is you want to look only in the numerator. So in this case, only x minus 4 is in the numerator. So x minus 4 equals 0, x equals 4. This is going to be the solution. Okay, extraneous solution, right? Because now you're probably wondering, oh, what about the x plus 3? That's actually going to be our extraneous solution. Because if you remember about making functions undefined, anything in the denominator is going to make it an extraneous solution, right? Because if it equals to 0, then that will make the denominator equal 0. So let's see, x plus 3 equals 0, x equals negative 3. And remember, x plus 2, these two cancel out. And yes, even though the x plus 2 is in the numerator, because it got simplified with the bottom, that's a whole, right? Which actually would also make it an extraneous solution, because if we were to have, oh look, negative 2, that will make the denominator equal to 0, which we can't have, right? So we actually have two extraneous solutions. whereby x cannot be -3 or -2. And that's the answer. So yeah, luckily on both the ACT and the SAT, normally they ask you for the solution only. So in this case, the answer will be 4. But every once in a while, they might ask you for the extraneous solution, right? Or in other words, what value of x would make the function undefined? It would be this. All right, so make sure you read the questions really carefully because of that. If you don't read it carefully, you will get it wrong. All right, so that's it for this pre-lesson. If you guys have any questions, as usual, send me a text message or an email, and I will see y'all soon. Have a good one.